Calculus 1, BSIE 1A, Charlie Team. Before we formally start this video, I encourage everyone to stay relaxed, have focus, and let us learn more.
Hi, my topic is partial differentiation. What is partial differentiation? In multivariable calculus, partial differentiation helps us examine how a function changes as one variable changes while keeping others fixed. This is useful when working with functions of several variables, which are common in fields like physics and engineering. Basic concept: function with two variables, f of x and y. Partial derivative of f with respect to x. Measure changes in f as x changes, keeping y constant. Partial derivative of f with respect to y. Measure changes in f as y changes, keeping x constant. These are some symbols used for partial derivatives. Our notation may be extended to a function of any number of independent variables. Thus, if u equals f of x and y and z, then we have the three partial derivative.
Here's an example of partial derivative. F of x and y equals 6x cubed y minus y cubed plus 8x minus 10. First, to find the partial derivative of f with respect to x, treat y as a constant and differentiate each term with respect to x. Here, y is treated as a constant, so we differentiate 6x cubed to get 18x squared and multiply by 1 y. Second, the derivative of negative y cubed with respect to x. Since y cubed does not depend on x, its derivative with respect to x is 0. Last, the derivative of 8x with respect to x is 8. And the derivative of negative 10 is 0. So leaving the final answer is 18x squared y plus 8. Second, to find the partial derivative of f with respect to y, treat x as a constant and differentiate each term with respect to y. First, the derivative of 6x cubed y. Here, x cubed is treated as a constant, so we just differentiate y to get 1, leaving 6x cubed minus the derivative of y cubed with respect to y is negative 3y squared, plus the derivative of 8x does not depend on y. Its derivative with respect to y is 0. And the derivative of negative 10 is 0. Leaving the final answer with respect to y is 6x cubed minus 3y squared. This is the final answer. Here's another example. G of x and y equals 5x squared y cubed minus 4xy plus 7y. To find the partial derivative of g with respect to y, with respect to x, treat y as a constant and differentiate each term with respect to x. So here, y cubed is treated as a constant, so we differentiate 5x squared with respect to x, giving 10x, then multiplied by y cubed. Second, the derivative of negative 4xy with respect to x. Here, negative 4y is treated as a constant. So the derivative with respect to x is negative 4y. Next, the derivative of 7y with respect to x. Since 7y does not depend on x, its derivative with respect to x is 0, leaving the answer with respect to x is 10x y cubed minus 4y. Next, to find the partial derivative of g with respect to y, treat x as a constant and differentiate each term with respect to y. Here, x squared is treated as a constant, so we differentiate y cubed with respect to y to get 3y squared. Then, multiply by 5x squared, giving 15x squared y squared. Second, the derivative of negative 4xy with respect to y. Here, negative 4x is treated as a constant, so the derivative of y with respect to y is 1, giving negative 4x. And the derivative of 7y with respect to y is 7. So the final answer is 15x squared y squared minus 4x plus 7. This is the final answer. Hello. Let's try this another example involving natural logarithm function. Let's try this g of x and y equals ln x squared plus y squared. To find the partial derivative of g with respect to x, treat y as a constant and differentiate g of x and y equals ln x squared plus y squared with respect to x. Let's view this one. So the derivative of ln u is 1 over u. Applying the chain rule, we get derivative of g, partial derivative of g with respect to x equals 1, and the u x squared plus y squared times the derivative of x squared is 2x, because y squared with respect to x is 0, equals 2x over x squared plus y squared. So the final answer is the partial derivative of g with respect to x equals 2x over x squared plus y squared. This is the final answer. And to find the partial derivative of g with respect to y and treat x as a constant and differentiate g to the x and y equals ln x squared plus y squared with respect to y. Again, using the chain rule, we get 1 over x squared plus y squared times the partial derivative of x squared is 0 with respect to y, and the partial derivative of y squared with respect to y is 2y equals, let's multiply this, 1 equals 2y
over x squared plus y squared. So the final answer is the partial derivative of g with respect to y is 2y over x2 plus y2. So this is the final answer. Let's try this example. F of x and y and z equals ln square root of x raised to 4 plus y squared plus z cubed. We can write it as f equals 1/2 ln times x raised to 4 plus y squared plus z cubed. We're about to solve the partial derivative of f with respect to z. So we're using the formula derivative of ln u equals du over u. So 1/2. So the derivative of x raised to 4 with respect to z is 0. And the derivative of y squared with respect to z is also 0. And the derivative of z cubed with respect to z is z 3z raised to 2 over x raised to 4 plus y squared plus z cubed. So the partial derivative of f with respect to z is, let's multiply that one, 3z squared over, put it with x raised to 4 plus y squared plus z cubed. That's the final answer. Let's try another example. Here is the problem. G of x and y equals x ln y plus y ln x. Find the partial derivative of x and y. To find the partial derivative of g with respect to x, we treat y as a constant and differentiate each term with respect to x. First, let's differentiate this one. Since y is treated as a constant, ln y is also a constant. So, the derivative of x ln y with respect to x is simply ln y, as a derivative of x is 1. So, ln y. Plus, here, y is treated as a constant, so this term requires the chain rule for ln x, where the derivative of ln x with respect to x is 1 over x. 1 over x. So the derivative of y ln x with respect to x is y times 1 over x. So the answer is y over x. That is the answer. Final answer. Second, we'll find the partial derivative of g with respect to y. Here, X is treated as a constant, so the term x ln y requires the derivative of ln y with respect to y, which is 1 over y. 1 over y. Therefore, the derivative of x ln y with respect to y is x times ln y equals x over y. X over y plus differentiate y ln x with respect to y. Since x is treated as a constant, ln x is also constant. The derivative of y ln x with respect to y is simply ln x, as the derivative of y is 1. So ln x. So this is the final answer. xy, again we use the chain rule. The derivative of sin u
trigonometry.
is cos u.
We have an example here.
F of x and y derivative of the inside function times xy with respect to y cosine times x. So the answer is y sine x times y. Cos first we'll find the derivative of partial derivative of f with respect to x. Plus here the derivative we use the chain rule. The
Cos
derivative
x
of
with
sine
respect to y
is
is
cos
0.
u plus the derivative
Cos
of
u
and the derivative
y
of
sine
the inside
times
function
y
x
with respect to y
and y with respect to x is y. So the
Y
answer is y cosine cos y times xy, and that's and the final answer
the
is
derivative of
cos x with respect to x is negative
x
cosine x times xy plus y. That's the
Cosine
partial derivative times y. F. This is the final answer with respect to x. Second, we'll find the partial derivative of f with respect to y. So, the derivative of sine times xy, again we use the chain rule. The derivative of sine u is cos u, and the derivative of the inside function xy with respect to y is x. So the answer is x cos sine times xy plus the derivative of cos x with respect to y is 0 plus the derivative of y sine times y with respect to y is y cosine y, and the final answer is respect to y is x cosine times xy plus y cosine times y. This is the final answer. We have another example here. F of x and y equals x sine times y plus y cosine times x. To find the partial derivative of f with respect to x and treat y as a constant and differentiate each term with respect to x. So, the derivative of x sine times y with respect to x. Here, sine y is treated as a constant because y is not a variable in this differentiation. So, the answer is sine y plus the derivative of y cosine times x with respect to x is negative y sine times x
So, this is the final answer. Next, to find the partial derivative of f with respect to y is the derivative of x sine times y with respect to y. Here, x is treated as a constant. So, the answer is x, the derivative of sine cos times y, plus the derivative of y cosine times x with respect to y is cos x. And this is the final answer.
And that is the end of this video. Thank you so much for watching, and I hope that you had a great time and learned a lot from watching. Please don't forget to subscribe to our channel.